Right there, top.
I know like the answer, but I want to know why I got the answer. So like I
Okay.
know whenever you do a fraction or ratio,
No,
usually
no,
you get
no.
it.
Let me explain, because I think you're looking at this incorrectly. This is not a fraction. This means take the derivative. It's
Okay.
important to know that means this is the derivative of 7 ln of x with
Hmm.
respect to x. That's important. That's what that means. Now we come over here, and to take the derivative of this, I'm going to first use this rule. What does that rule say?
Derivative of x.
Wait, no. K is always a constant. Do you understand what a constant is?
Hmm.
X isn't a constant because it's variable. It can change. It can be whatever we want it to be. But 3 is
Right.
always going to be 3. Pi is always going to be pi. Those are constants. K here on the formula sheet are constants. This is very important.
Yeah, like
So
mine, I guess my issue is more trying to look at the problem and then recognizing which derivative
what I'm going to
formula
do,
to
we're going to do
use.
that. That's what we're going to do today. I'm not going to let
Okay.
you go until you know how to do this, I promise. Do you see here, we're basically taking the derivative of this.
Yes.
Everywhere there's a formula here with a K in it, it's a constant. That means that here, this is the same as K f of x, where K equals 7 and f of x equals ln of x. Does that make sense? Since I want to take the derivative of that, it's the same as taking the 7 out of the derivative. And this is also means derivative, right? The prime, the little line, these are both derivatives. I can write this as k f of x prime. Same. Basically, all I'm doing is I'm allowed to take the k outside of the derivative. Any constant can come out before I take the derivative. This is the same as 7 times the derivative of ln of x, right?
Right.
Yes.
And what's the derivative of ln of x? It's on the
Uh,
formula sheet. Look at the formula sheet. Don't look anywhere but the formula sheet, because this is what you have on the test.
1 over x.
Exactly. This equals 7 times 1 over x, which is the same as 7 over x.
Yeah, no, that makes more sense now why it's 1 over x, because I was wondering why that
Right.
is.
That's why I'm saying we have to really understand this formula sheet. Once we get really clear about what this formula sheet means and how we use it, it's going to be easy. That's why I'm going to spend a lot of time going back and forth to the formulas. Once you get used to them, and you will, because you're going to do the same ones over and over again, it'll be easy. Don't worry.
Yeah, that makes more sense. Thank
Okay.
you for explaining that. That was helpful.
Yeah, no, that's what I'm saying. When you ask me a question, if you don't understand that, do you see that I know that you don't understand the formula sheet? Because once you understand the formula sheet, there's nothing else for me to explain there, right?
Yeah, that's true. That makes more sense. Thank you.
Oh, my pleasure, my pleasure. I am listening to you, I promise.
Yeah, no, I agree.
Use this to find the equation of the tangent line to the parabola at the point -338. That means x is -3. I want to know what f prime of x is, and then I'm going to plug in -3. If f of x equals 2x squared minus 5x plus 5, find f prime of -3. That's the question. Now, I don't know what to do, right? Use this to find the equation of the tangent line. This is really important to the parabola. This is a parabola, 2x squared minus 5x plus 5, right? We know it's a parabola because it's x
Mhm.
squared. And then at the point -338, that means they've given us x equals -3. After we find the derivative, we can plug in -3 and find out what the derivative is at that point, right?
The derivative, I guess, like, I know it's like the tangent line, right?
Wait,
It's
wait,
like the
wait.
same.
I'm going to explain what the derivative is in a minute. But first, I want to just make sure you understand what the question is asking. Don't worry, I will get to all of it, I promise.
Yeah, I think that makes sense.
So far, what I've said makes sense.
Yeah.
And then it says the equation of this tangent line can be written in the form. They want it in this form, mx plus b.
What it's asking you to do is to find an equation in the form of y equals mx plus b.
Of the tangent. That's the question. It says use this to find the equation of the tangent line. That part is the same. But notice what they're asking me is the most important thing I'm going to say is the equation of the tangent line. If they didn't say y equals mx plus b, what I know is that anytime I want an equation of a line, it's either y equals mx plus b, or you can use y minus y1 equals m times x minus x1. Either one. In this one, you have to use y equals mx plus b, and there's a certain reason for it, because they're asking you what m is and what b is. They're not asking you for the equation yet. If I want to write an equation of a line, y equals mx plus b, what can I do to find m and b? Because I don't know m and b yet, do I?
No.
What should I do? Here's where we're going to go back to what is the derivative. What is the derivative? Just from what you remember, I don't want you looking at your notes.
What I remember from the video was that the derivative is the slope of the tangent line, the difference, how, I guess, the speed of something on the line.
That's what it is. I'm going to explain why it is that, because it's super important. Because if you understand what you're doing, it makes it so much easier to do than if memorizing words that have no meaning to you. What the derivative is, if we have a graph, let's say my graph looks like, and I want to know what is the slope of the line at this point. Well, I don't know. Do you? Even if I tell you that this point is -1, 2. I just made it up. Doesn't really matter.
Sure.
Well, I can't do m equals y2 minus y1 over x2 minus x1, can I? Because if I do that, then I only have one point. They're the same. I end up with 0 over 0.
Yeah.
Does that make sense so far?
Yeah.
Yes.
That's where the derivative comes in, because what we want to do is we want to find a point. Let's say we take a point over here and I connect these 2 points. Let's call this x1, y1, and we'll call this x2, y2. I know now I can find the slope of the line that connects those 2 points, can't I? y2 minus y1 over x2 minus x1. The slope of the line at that point. Let's take this point and we'll move it closer. And now I have a new point. And now notice the slope changed quite a bit, didn't it?
Yeah.
So I know I must be getting closer because I'm getting closer to that other point. Now let's pick a point even closer. Let's pick a point here. And now let's connect these 2 points. Now it's a different slope again, isn't it?
Yes.
And as this point moves closer and closer to this point here, I'm going to be able to get the slope of the line at that point. If I can get that point, the other point, so close that I don't know that there's that much difference. Because let's say I were to take a microscope really close together, and I'm still connecting them together, and there's still a line, right? So I can still find the slope, but they're so close together that I can't tell the difference. Are you with me?
Yeah.
Yes.
Can you see that would give me the slope of the line at that point? Does that make sense?
I guess the closer you get to the point with the tangent line, the better it is.
Right, because
Basically, like the tangent line is like the rate of growth of the point.
Wait, slow down. You got to know what the tangent is first. And those are things it represents and you can use it for. But first you have to understand what you're getting. Why is it the slope of the tangent line? What does that mean? Right? Doesn't that make sense to have to know that before you start understanding how everything interacts with each other? So if I get really close to this other point, so close that I can't really see that they're a different point, and I connect those 2 dots together, I'm basically getting the slope of the line at that point, right? And it's since it's just at one point, It only touches the graph at that one point, and it's called the tangent. Anytime a line touches a graph at just one point, it's tangent to that graph. So let's say I have a circle, and I have a line that's only going to touch this circle at one point. So it would be there, right? That's a tangent line. If I went through and touched it at 2 points, that's called a secant line.
So tangent lines have 1 point and secant lines have 2 points.
Secant lines have more than 1 point. Yes, tangent lines only can touch the graph at 1 point. A secant can go through at more than 1 point. It can go through at 2 or 3 or more. Like if I had
Okay.
this graph, I can make a line that went like that, and it goes through that graph 3 times, doesn't it? But that's not a tangent line. Tangent line has to hit it exactly one place. And that'll give me the slope of the line that's tangent to that point, which we can't get on a graph that's changing constantly without taking the derivative. Because what the derivative means is, I'll show you. So if you saw, the definition is the limit as h approaches 0 of f of x plus h. And I know this is not stuff you're going to work with, but I really want to go through it so you can kind of see how it all works. Now, I'm going to pick 2 points here. I'm going to say this point right here, this is x, comma, f of x. So I don't know what number that is, but it's some x, and then f of x is the y that goes with it. That makes sense, right?
Yes.
Now I'm going to pick another point. I'll use this one right here. And I'm going to say, if this is x plus h. So this is some distance here away. What is the distance? I don't know. I don't care. It's h away. If you say h is 3, then it's 3 away. If you say h is 10, it's 10 away, right? Good? That may make this point x plus h, comma, f of x plus h. Right? The x and the y. Does that make sense? Well, this is like, I just replaced this with x. And if I put whatever number this is into the function, I'll get f of x plus h. Like if this is x is 1, y is 3, and I say h here, let's say h is 2, this is -1. So here, this would be 1, comma, 5, right? Because I'm 2 away from the old value. That's what h is. But I can make h 3, and then I would be at 2, comma, some number, right?
The x I get x plus h is because it's
Just
like
making it up.
Oh.
I want it to be some distance away from the original point. I don't want to name the amount away it is. So I'm going to have my x, and I'm going to have my x plus some value.
Could you describe like how you get this? Because like, I understand
Yeah,
this. I just don't know.
Good. Yeah, of course. Yeah, no worries. So if this point right here is x, I have y equals f of x, right?
Mm-hmm.
And if I have, so I want my point xy. Yes?
Yeah.
So this point right here is x, comma, and I said it's f of x, right?
It makes sense.
Good. Now here, what's my y?
I
Or
guess
what's
the
my
h.
x value? What's my x value there?
I get the x plus h.
X plus h, thank you. Because I shouldn't call it x, but yeah. So what's my horizontal value there? It's x plus h. Whatever my original x was, I'm going to add some number to it. You name the number, I'll add that.
3.
Right? So that means this point would be x plus h. And then if that's x plus h and I plug it into f of x, won't I get f of x plus h? Like if this is 2 and I plug it into my function, I'll get f of 2. Let me do it better. Let me give you an example that's more solid. It's a little abstract, so let me solidify it. let's see, let's make a graph. So we have this point here and let's call it A because X is confusing.
Sure.
Whatever A is, I don't know. And then I want to find another point that's a distance of 5 more than A. So I'm going to come over here and let's say this is -2, just making numbers up. So
Okay.
5 more would be 3. So now here, let's call this A1 and A2. So A1 is -2, A2 is 3, and the distance between these is 5, right?
Yeah.
Can't I say that A2 is equal to A1 plus 5?
Yes.
Okay. And then can I say that A2 equals A1 plus some amount, I don't know what it is. This is going to be A1 and this is H. So then I'm going to add H to it. Does that make sense?
Sure.
It
Yes.
does? Good.
Yeah.
So now I have 2 points, A1 and A2, and I know that actually A2 equals A1 plus H. So instead of making 2 different variables, I'm going to make this A1 plus H. Now, let's say here, I plug in F, so f of x equals, I don't care, x squared, just to make it not so abstract. I plug in A1 for x, and I'll get f of A1 equals A1 squared, right? Good?
Yes.
So I'll have a point here, A1, comma, f of A1. Or I'll have A1, comma, A1 squared. Here, if I'm going to have a point, A1 plus H. I don't know what the point is, but I know whatever A1 is, I'm going to add some value to it. I'm going to call it H.
Yeah.
So far, if I want to know what f of A1 plus H is, it's going to be A1 plus H squared, or f of A1 plus H. Because I said f of x was x squared. That's the only reason. If I didn't say it was squared. If I didn't say it was, I mean, I just made up a function so we could like use it. Like I could say A1 is, I could say A1 is -1. F of A1 is 1 because it's squared, right?
Is this squared?
It depends on the function, right?
It depends on the function. It's just because I'm saying it. I'm
Okay.
stating what my function is. If I don't state what my function is, then it's going to be f of x or f of a or f of a plus h. Let's say it's x squared and f of a1 plus h is equal to a1 plus h squared because I just plug in to x, right? Everybody understands this.
I
Yes.
think so.
Yeah. I think it's for me, it's more of the order of what to do next is
No,
what I
just want
struggle
you to,
with.
no, I get it. I just want you
Oh,
to first understand what we're doing. Because if
Yeah.
you don't understand this, it really will get out of control. It'll just be something that you have memorized and you won't understand how it applies to everything. Because from now until for a while, we're going to be doing derivatives and then we're going to be applying derivatives. So if you don't know what derivatives really are, it's hard to apply them and understand what
but
you
I
do.
still, I mean, I guess I would say that I don't understand like how, like what it is in sense of like how to describe it, I guess. It's like,
I'm going to get there. If you can just
oh,
follow
okay.
me, if you follow
Okay.
me, we're going to be great. But if you can't follow me, that's when I kind of go off into another little side piece. So can we relate this now back to my original graph here? Perfect. That's all I wanted to do. So now now we're back to what is the derivative. See, the thing that you guys want to do, and I don't blame you, I do it too. We all do it, is you want to get to the answer as fast as you can without understanding what you're doing because you just want to get it over with. And what you want to do, if you can understand what's happening first, everything else gets a lot easier because you don't have a bunch of notes that you don't understand. You don't like once I explain it to you and you understand this, you're going to be great. So now I'm trying to find the slope of the line at that point. And if you remember, so let's say the slope is going to equal, well, actually, that's the slope I'm trying to find right now because I'm using 2 separate points. And I'm going to say the slope is equal to, well, y2 is f of x plus h. and y1 is f of x. x2 is x plus h, and x1 is x. Do you agree with me there?
I'm just trying to see it.
So this is
Yes.
like, this is
Yes.
point 1, and this is point 2. y2, this is y2 minus y1 over x2 minus x1.
Yeah, it makes sense.
Perfect. So you agree that this is the same as the slope of the line.
Yeah.
Yes.
So now I'm just going to simplify this. Because if I take off my parentheses here, I have x minus x. And this is just over h, right?
Mhm.
Good. Now, remember what we did before? We said the closer that this gets to this point, the closer we get to the slope of the tangent line at that point, right? Is everybody with me?
Yes.
Smaller h is the closer it is to the original x, right?
Yes.
Right.
Good. So that's where the limit comes in. Did we go over limits yet?
Briefly. Very.
So let's just say we went over limits. You have barely an understanding, but what this means is I want h to go to 0, but I can't make it go to 0 because if it was 0, then I would have f of x minus f of x over 0. I would have.
So I
Yeah.
have a question.
Yes, please.
Is this something that you need to consider every time you're solving for this type
No.
of problem?
No, you
Oh.
just have to follow me. I'm going to really bring this back to where it needs to go. I promise. I absolutely promise. So as this point gets closer to this point, I get closer to the slope of the tangent line. Do you agree? This is the definition of the derivative. So now that we know this is the definition of the derivative, we also know it's the definition of the slope of the tangent of the line that's tangent to a curve at a point, don't we? And I'll say it again. This is the actual definition. So, like, you can't change the definition of something. And what this definition means is exactly what we said. H is going to get so small, it's going to be 0, and we're going to get to that line, and we're going to get the slope of the line that's tangent to the curve at that point, because we started off with the slope, didn't we?
Yeah.
And we got to here, all we did is change to get from M to the next line. I just put the fact that I want H to be as small as possible because I want it to be like 1 point, right? It's the only thing I did different. That's the definition of the derivative, which also means that it is the same as the slope, but it's the slope. It doesn't have anything to do with anything else, but it's the slope of the line tangent to a curve, any curve. And when I say curve, I mean the graph at a point, because it's going to change. Like if I want the slope here, it's going to be like that. That's different slope. Because the line is not straight, it's curved, the slope is going to keep changing constantly. That's why we need derivatives. We can find the slope of a line with just 2 points because it's constant. But when a curve changes, you can't do that. So you have to use the derivative.
Okay.
Does this make sense now?
Yeah.
Completely.
Can you explain the last part again?
Which part? So from here?
Yeah, the explanation of the definition. So because
Yes. Let me go back. Let me see what I can erase so I can make it less confusing. And we said that's the slope of any line that has 2 points, and I don't know anything about the points except they're h apart. That part you understood?
yes.
Then I said, well, if I want to find the slope of just the line that only touches the curve at 1 point, right? I need h to be really small because, like, the closer they are, the closer I get to the actual slope at that point. As this point gets closer and closer to this point, so it's moving around the graph, right? It
Right.
can't go anywhere but along the curve because it's part of the curve. But I'm just taking different x's and I'm getting closer and closer to this x right here, which is what I want to know the slope of the line at that point.
So that's why as the number gets smaller, it's closer.
Right, because this is h away. So if h was 0, x and x would be the same, right?
Yeah.
Right.
But we can't make them the same because we can't find 0 over 0. So we're making them so tiny apart that we can tell. And there's no way to really do that except with derivatives. That's what derivatives are. And so as h gets smaller and smaller, it becomes closer and closer to x, doesn't it?
Okay.
So what I want to do for the definition is I want to take the same formula as the slope, but I'm going to add that part on, which says I want to make h go to 0. That's the definition of the derivative. Notice this part is exactly the same, right?
Right.
The only thing I added is please make h 0. But I can't make it exactly 0. I want to make it as close to 0 as possible.
And that's why the arrow is there to make
Right. That
right.
means that's what I'm saying. I didn't know if you guys watched the limits videos yet.
Yeah, it was like the
did.
previous chapter.
Oh, good.
Putting it
Yeah.
together and applying it to the word problem is where I get a disconnect.
Right. Exactly. But that's because you don't understand what's really happening. That's why I went through this. I know it seems like I'm going off topic. I'm
Oh,
not.
it makes sense actually now.
See?
It helps me a lot.
Once you understand what's happening, like you won't have to keep thinking of what's the definition and how do I apply it? I don't even know what the definition means.
Yeah,
Right?
understandable.
So now you can close up that. Let's go back to the question. Because honestly, at this point, I don't need all that. I want the equation of the tangent line to this parabola at a point. Well, that means I need the derivative, don't I? That's what the derivative is. It's the slope of the line tangent line at a point. And that point they're giving us is -3. They may not give us a point, in which case the derivative is in terms of x. But here they want to know what it is at a certain exact point. Do you understand it from the question now?
Yes.
To find the slope of the line, I need to find the y-intercept. Well, how will I find the slope of the line at a point? Oh, that's that's what the derivative is. So I take the derivative of that equation. And I want you to read that question over, and I want all three of you to answer me, yes, I understand the question, and I could understand it now if I saw it without looking it up and trying to figure out what it all means.
Yeah, I think.
Yeah, it makes
Yes.
more sense now. When I
See,
read it, now I
it seemed
understand
like- I
better.
know it seemed like I was going off topic. The explanations are important because they make you understand things that you don't understand. I mean, sure, I can teach a 3-year-old, maybe not a 3-year-old. I can teach probably a 10-year-old how to use that formula sheet, but I probably can't teach a 10-year-old how to think in terms of something abstract like we just did.
Yeah.
That's the difference. Here we go. The first thing I need to do is take the derivative. Do you know how to take the derivative of that?
Then you put -3.
No, you don't do that first. First, you take the derivative of this, because if I plug that number in first, what will happen? Just think about
You're-
the question. You'll know the answer. If
You're
I
gonna
plug
get
in
f
that
of
number
x.
first, what happens?
You're gonna get f of x.
I'm not going to get f of x. I'm going to get f of -3. And what is
Yeah.
f of -3 going to be?
It would be like you would plug in the -3 into
It'll be
x,
the
right?
function.
But it would be a constant. Once I plug that number in, I'm going to get a constant. I'm going to get a number out.
Exactly.
And if
Yeah.
I take the derivative
Yeah.
after I put that number in, what am I going to always get? What's the derivative of a constant?
0.
Exactly. If I plug in that number first, then I take the derivative, I'm always going to get 0. which obviously doesn't make sense. Otherwise,
Okay.
we would just teach the course that the derivative of anything is zero. We
Yeah.
wouldn't have to go any further.
No.
Perfect. I have to take the derivative first because I want to know the equation of the slope part, because remember that equation is going to give me the slope of the tangent line. And then I plug in the point and then I'll have it at that point. Yes?
Yes.
All right, let's do it. Do you know here the first thing we're going to do is we're going to use this, just so you understand the formula sheet. This, what does that say? I'm going to walk you through this really super slow. You do not have to go this slow when you do it on your own. I just wanted you to see all the steps. I start out with f of x, you can too, but I'm just going to go slow. The first thing when I want to find the derivative is I don't see over on my formula sheet a derivative of something like this, do I?
No.
Well, what can I do that will make it closer to what I have on my formula sheet and ignore everything over here? Honestly, there's nothing there for you yet. If I use this here, what does that say? What can I do with that? I want to make sure you understand what that means because we've already used this. We know what that means.
Yeah.
Let's see what the next one means.
Is it the second one we can use?
The first thing I want to do, I'm going to point out where we're going to go because you
Okay.
can do it much faster than the way we're going to do it. I'm just going to do it super slow and then we're going to speed up. The first thing I want you to do is use this. And what does that say?
Derivative over derivative of x.
Don't worry about that. This just means you can say the derivative. I'll
Okay.
teach you what that means in a little bit because I like that notation a lot for later, but for now, just read it as the derivative. That says the derivative of
Derivative of f of x plus or minus g of x.
equals what? In the derivative, f prime of x?
Yes.
Yeah.
The derivative of f of x plus or minus g of x is equal to the derivative of f of x plus or minus the derivative of g of x. We don't have to take the derivative of both together. We can separate it into pieces. That's like saying it's the same as the derivative of this. And I'm just going to put the primes here. Minus the derivative of this plus the derivative of this. That's what that second line says. I can separate it into each one of these when there's a plus or minus between them into different.
Oh,
Oh.
Can you see it now?
yes.
Good. Do you see how this is helpful?
Yes.
Let's just keep going. That's what I'm saying. Because now we're like learning how to use the formulas. Because once you learn how to use these formulas, everything is going to get easier. The only thing we did so far is use, I'll call this number 2. All right. So this is
Got
number
it.
2.
Yeah.
Now,
1, 2.
Oh, so you have to go by
Seven?
steps. So you might have to use
Right.
more than one.
you're going to have to use quite a few, but you'll
Oh,
get
this.
you'll get them and you won't need to go step by step
Oh,
on this.
I didn't know that these were like, I just thought they were like separate
They are, but they're steps. Now I'm here and I want to take the derivative of 2x squared first. What's the next step I could use? I want to use number 1 next because this is the same 2 times the derivative of x squared minus 5 times the derivative of x plus the derivative of 5. Yes?
Yes.
And this is from using number 1. Now, are you going to do all these steps? No, I'm trying to tell you you're not. But if you don't understand the steps, then you can't skip that.
Yeah.
So far, you're with me.
Yes.
Yeah, I wasn't thinking about it that way.
Good. Now, what's my next step?
3.
What is it?
This one.
Yeah. 3 says if I have x to some power, that's what n is, and n is a constant. It cannot be a variable. Okay, so n there is a constant, and I have a constant, I have a 2. Yes?
Mm-hmm.
Yes.
So if I use number 3, I'm going to run out of space in a minute. I'm going to get 2 times, well, the derivative of x squared, n is 2. I say 2 times x to the 2 minus 1.
It's yeah. I see that. I see that.
Can you
See it?
repeat that? Yeah, you kind of lost me.
And I'm changing color because I'm going in a different stream now. Oh, that's great. Now, the next step, let me do it like this. I'm going to do is number 3. I have f prime of x is equal to 2 times, well, now I need the derivative of x squared. And the derivative of x squared is in here. Because see, x to the n power. N equals 2. For x squared, n equals 2. I'm going to write this as the derivative equals 2 times x. And if it's with you, I'm just going to say 2 minus 1 is 1. That's my derivative. If you want me to put all the
Yeah.
pieces in, I can.
No, it's fine. I understand that part.
Everybody's good?
Yeah.
Yeah.
Yes.
Good. Now, minus 5, because I already did that. Now I need the derivative of x.
1 minus 1 is 0.
Sure, but what does that mean? The derivative of x, there's 2 ways you can look at it. The way you looked at it just now is perfectly fine because, first of all, it is here, but I'll explain why it's the same. If I have x to the 1 power, this is equal, the derivative of this would be equal to 1 times
1
x to the 0
x
power.
to the 0 power.
Well, what's anything to the 0 power?
It's
1.
1.
1 times 1 is 1. The derivative of x is always 1. You don't need both those pieces, but there you go. You can use either 3 or 4. It works both ways. You with me?
Mhm.
Yes.
That means this is 5 times 1 plus the derivative of 5, which is
Nothing.
0. I'll write plus 0 just so you see where it's coming, what happened. And now the derivative is equal to 4x minus 5.
Yeah, how is that 0? I'm sorry, can you break
Because the
that
derivative of a constant is equal to 0. You can ask me later, and it's an easy explanation, but I don't want to go off on a tangent.
Yeah, I understand.
So far, you understand what I did.
Yes.
Now I know that the derivative of this function is equal to 4x minus 5 anywhere on this graph. But that's not what they're asking me, is it? They want to know what the derivative of the function is at a point. Let's do this. Now I want to know what is f prime of minus 3, don't I?
Yes.
And then from there, you can just substitute the x.
Exactly. This is minus 12, minus 5, which is minus 18. And that is the slope of the tangent line, x equals minus 3. Because this graph is not constant, it's a parabola, it's going to keep changing. But at minus 3, that's the slope.
Gotcha.
And then so
Are we good?
b would be -5.
No,
Oh,
no. This is not the equation of the tangent line. This is the slope
oh,
of the tangent line, only m, where m is negative 18. Can I erase everything now?
yeah.
Yes.
Here we go. Now I know y equals mx plus b, and I know y equals negative 18x plus b. And I know that I have this point and it's going through that point, that line, that tangent line's going through that point, isn't it? I know
Yeah.
X and Y. I have I have 38 is equal to minus 18 times -3 plus B. This is 54 plus B. I subtract 54 from both sides and I get -16, I think, equals B. And you guys should check me on that. I did that really fast. I wouldn't trust that number, but I want you to see what I did. I just plugged in that point there because I know I have y equals mx plus b. I know what m is now, minus 18. I plugged in -3 for x and 38 for y, and I found b. As long as I did,
Oh, gotcha. That makes
if I didn't
sense.
make an error, that's what it is.
I think for me, what I struggle with is the first part, not this part. This part I understand very well, but it's just going through the steps and figuring out which step applies to how it
You got them both
looks.
wrong? Wait, let me see. Let me go through and do it real quick. Let me do it without all the steps.
This
Hold
feels
on.
like how I feel during
4x, y, and -3 is -12, -5. Oh, it's -17. Yeah, it is -17. I just added wrong. And I told you
story of my life.
that. And that's going to make the second one wrong for sure. Then we have 38 equals -17 times x, and x is -3 plus b. This is equal to 51. And that would make this 13 negative. Oh, yeah. Because I'm just this is plus b equals 30.
Yeah.
And then I'm subtracting 51 from both sides. That was my mistake. I added wrong.
Yeah, I wrote it wrong too.
So
That
it
makes more
makes sense
sense.
now?
Yeah, that's
Okay,
very
so now,
helpful.
good. Now let's see if there's another problem that you need to use the same thing for.
Just a minute.
I think the
Okay, so
next one.
Yeah, just click next. You guys, I'm not going to do it. You guys do this, see what numbers you get. And if you don't get the right numbers, I'll go through it step by step.
Okay. On top of the E, it's an X
E to
Yeah.
the X powered.
to the X.
E to the X. How close to you guys? You getting there? Is anybody completely
No,
stuck?
I'm completely stuck. I'm not gonna lie.
Yeah, me too.
I'm trying to figure out which
We're
one.
getting there.
Okay, no, listen, I don't care. I just needed to know. I like if you
I'm
need more
stuck
time,
on
I'll
finding
give you
the
more time. If
derivatives.
you're stuck, then I can give you a month, and it's not going to make a difference.
I mean, I recognize what to do, but
What? Tell me what
I
to
get
do.
I'm finding the derivative of 10x,
Okay,
then
so what's
8.
the derivative of 10x? So if we don't go through all the steps, and we kind of
I'll put is
ahead.
it 1?
No, but you're closing
No.
in on it.
I know
So
8 is 0.
8 is 0.
Mhm.
I'm going to write the derivative is equal to 10 times the derivative of x.
Yeah.
And the derivative of x is 1. It's 10.
I think but where from the formulas did you see that the
Okay,
derivative
I see.
of x is 1? Because maybe I'm missing it. How did I know that the derivative of x is 1?
Oh, here. And there's two ways you can look at it.
That's what I'm saying. Like, I don't see that part.
There.
Oh, derivative of x is 1.
Also, right here.
Oh,
But look, it's also here. If I have x, it's the same as 1x to the 1 power.
yeah.
Well, that means I pull down my n is 1. I have 1.
Yeah.
Sorry, that 1 should x to the 0 power. And x to the 0 power is?
Or
Anything to the 0 power is? 1 times 1 is?
One.
So
Yeah.
it's this. You can use that, or you can just know that it's, do whatever you want. Once
I
you have
didn't.
the
I
formula
didn't
sheet,
realize
I don't
that.
care what you do. Excuse me?
No, I said I just wasn't. I didn't realize that.
Both of those are the same. This one's a little different. I could show it to you, but I won't.
Yeah.
But it's right there. The derivative of a constant is 0. I'll show you real quick. Look,
All right.
I
So,
have a graph of
so
a
you-
constant. Look, I'll show you. Let's say I have y equals 5. The
mhm,
graph of that looks like this, doesn't it?
yes,
What's the slope of that line?
0.
The derivative of a constant is 0 because it's the slope of that line.
Oh, I'm sorry.
Together,
Yeah.
and see how when you fit it together, it's like having a puzzle of the pieces, and you know they're there, but you can't really put them together well. But once you put them together, it's like you can see the whole picture. That's why I want to fill you in on these little things. That means the derivative of 10x is going to be 10. And if you don't understand why, I'll go through steps.
So that makes sense.
1
Because the derivative of
minus.
First, I
X
use
is
this.
1, and then you multiply by the 10, and that's what's
Exactly.
10 times 1 is 10.
Exactly. Good.
Yeah.
Yes.
The derivative of 8 is
0.
perfect. And then I have minus 15
15.
times the derivative of e to the x,
X.
which is
E to the x.
X.
exactly.
Good, I got that. Okay.
Okay.
I was doubting myself. Yeah.
Now it says the equation of if it says the equation and it says y equals mx plus b, I need y equals mx plus b. What does this give me? And it wants it at this certain point. What does the derivative tell me? I took the derivative. What do I get from the derivative?
Get the y.
Nope.
Like the f of x is y.
Nope. I get the slope of the line tangent to the curve. I keep saying it over and over again because I promise you, as I say it, when you're taking your test and doing your homework, my voice will come to your head.
Hopefully.
Yes.
Question. Can we redo the homework like to practice?
Yes.
Yeah, absolutely.
Oh, I thought once you submitted, you couldn't go back and look at the questions.
We're doing that right now.
Oh, okay. No, I mean, I didn't know that you can like click back on it. Like, you know how sometimes when you
can click
submit
on it,
something.
you can go through it, but it doesn't change your grade. But you can go.
Oh, okay. That's
Submitted already. It won't. I can use it now after because it's after the due date. I can just.
okay. And they'll keep on giving you more.
Yeah,
like
you can
when you do the refresher.
Like,
Yeah.
yeah.
Oh,
The
I didn't know
problem is
that.
yeah, you can practice all you like. It's just that only before the due date do you get credit. After
Oh,
the
okay.
due date, you don't. That's
Oh, I
all.
wish I would have known that.
Oh, okay.
Well, now you
Yeah,
do.
because I think I'm gonna do these a lot. I need
Yeah, I
to
have
practice.
to.
Good. It's good. Honest, it's good.
All right, and then now we can
You can
do
even
this.
go in, you can go to Google and you can say easy derivative problems or whatever worksheet with answers. Always ask for with answers. So you can go through and just do some other problems that aren't here. Because taking the derivative, it doesn't really matter. It's always going to be the derivative.
Mhm.
You just want to avoid things like sines and cosines and stuff because we don't do that in this class. If it has, that's why I'm saying easy. You just want basically the power rule, which is this, and like e to the x and ln. I mean, there's not really, we're not doing a lot of derivatives in this class. You just need an easy sheet of just pop through them. I promise it's going to get easy once you start doing this.
And then also keep in mind for the review, like it's only open that day. You can't do the
Yes.
review over and over again. Like I thought you could,
You can,
but you can't.
on
You
that
can only
day.
do it that day. You can
Right.
only do it over and over again that day,
That
but
day. Yes.
which is that Thursday, but you
Yeah.
can't do it Friday at all.
But you can always go back to the homework on Friday,
Yeah.
but not for credit because it'll be due already. It's going to be due by the day of the quiz, because the quiz really is like the prep. You'll see where you are with the quiz for the test. So you should be done with all your homework. And you should be able to take the test that day on Wednesday. And that's what the quiz is. And then if you do well, it's like, I really did get this. And then you're ready for the, I'm not saying don't study anymore. I'm saying, but then you're ready for the test.
Mm-hmm.
Does that make sense?
Yes.
Good. Everything does make sense if you think it out, but I know it seems random, like we just make up random rules. It's not so much that. I'm here.
Yeah.
Well, I need the slope because that's my first question. I have the derivative. What do I do?
You plug in something for x.
Yeah, what?
0.
0.
Yes, because it's
Oh, I got it. Woo!
because that's
Okay.
the point that they're saying they want the slope at that point. I'm sorry, they want the equation at that point. So I need the slope at that point.
Mm-hmm.
I plug
So
in.
then it's net.
So yeah, I get 10 minus, and anything to the 0 is 1, but 10 minus 15 equals minus 5. And hopefully I didn't do my math incorrectly, my arithmetic incorrectly.
Yeah. Then
Why did we not have to plug in the 7?
Well, because this is asking me at x, what is it? Now we do have to use the -7.
Wait, can you go back to how did you 10 minus, how did you get just 10 minus 15?
I plugged in, I have here, f
You used that
prime
one.
of 0, because I have 0 is the point that they're last time was f
For
prime of
x.
-3. Now it's f prime of 0 because they're giving us just a different point. They could give us f prime of 20, and then we would have a different number. Although it wouldn't be so easy to do without a calculator. 0 is a nice one for e to the x.
The term prime and derivative is interchangeable.
Interchangeable, yes. Sorry. They're exactly interchangeable. They mean the same thing. I'm going to use this, I think, quite a bit. I do in my regular calculus class. I think I do in this class too, because there's some times when you really do need that, but this is like shorthand. That's all it is. It's shorthand. But this is important. You have to know some things about that. And I think
do -5x plus b equals.
that's b here is -5. I mean, m is -5. Now there's two things you could do here. What's the rule for the y-intercept? How do you find y-intercepts?
You plug in something for m.
Nope. No, in general, Lauren, I know you know this. We went through this 100 times. How do you find a y-intercept? How do you find an x-intercept if you're given an equation?
If you plug in the
So if I want
numbers,
to know the y-intercept of anything, what do?
you plug in the points.
The substitution from the points, the given point.
Don't look at this problem, just in general. It's a general question. I want to find the y-intercept of anything.
It equaled it to 0.
What equal what to 0?
Y?
No.
Yes.
X to 0.
F of x?
Yeah.
I want to
Equal
find
x to 0.
Then
Oh,
y
sorry.
equals 0. And if
Yeah.
you don't know y, look at any graph. If I want to find the x-intercept, no matter where it intersects the x-axis, y is equal to 0, isn't it?
Mm-hmm.
Y'all see that?
Yes.
Good. And no matter where the line hits the y-axis, x has to be 0, doesn't it?
Yeah.
That's why you don't have to memorize it. You just know, if I want to find the y-intercept, x equals 0. Always.
Yes.
And the x-intercept, y has to equal 0, always. Well, they were really nice to us because they gave us x equals 0, which is the y-intercept. If they didn't, you could plug in y equals -5x plus b, and then we can plug in -7 for y, -5 times x plus b, this becomes 0, and then I would get the same thing.
B is just -7.
Exactly. But if you just could recognize it, because if x equals 0, we do have the y-intercept, you're a little ahead of the game.
Yeah.
But I'm just pointing out stuff. I'm not
I
saying
think
that's
for me, it's trying to figure out the combination of what can go together and what rules apply to. I think I'm
Okay, so
struggling
here's the
to
rule.
attach the algebra to the calculus.
Got it. Here's what we're going to do. Here's what we're going to do.
Like when I know I
If
can
we
do that
wanted
from
to
when I
okay,
can't
so
do
here's-
that.
here's- let me see if I can break it down. Maybe I'll try to make a flow chart or something. Maybe
Yeah, that's what it is. I don't understand the flow
Yeah.
of
yes.
like when to apply things.
Yes. I might go back to that white screen again. Let me see if I can write a flow chart. Ask me the question one more time.
No, I'm saying I understand all the smaller parts, but it's
Mhm.
putting it to the bigger picture, applying it
Okay,
to the
flow
bigger
chart.
picture is
That's
where
what
I
I'm doing.
struggle.
First thing
Yeah.
we want to do is we want to understand at the top, what is the derivative? What is the derivative? If I get this really well done, I can just draw it up with real tools. What I want to do is I want to start with the derivative is the slope of tangent line at point. And sometimes we don't know the point, so we leave it as f prime of x. Sometimes we do know the point and we can find out what the actual slope is, like the actual number. If I want to find the tangent line, then I need to take the derivative, and that equals the slope.
No, it's supposed to be.
Yeah.
And then for these questions, if they say y equals mx, a lot of them won't say y equals mx plus b. They'll just let you put in whatever form, and the other form is better usually. This one's just what they're asking for. To find b, plug in xy, which will be given.
Mhm.
So this is the order of how you solve.
That
Question.
problem. Yes,
problem.
that question.
Mhm.
If it says find the tangent line, you take the
That means you
derivative first and
Right.
then plug it, and that gives you the slope. If you have the xy, I guess I should say, if you have the xy, you plug it in. If you don't have the xy, then you're done. The slope is in a function. It's not a number.
If they don't give you a point in the
If they don't give you a
question.
point, you can't answer it because it's different at every point. Sometimes you'll just be asked to take the derivative. And then they won't give you a point, and the derivative of x squared is 2x. Period, end of story. If they say, what's the equation of the tangent line at that point, at point 3, 9, now you have to plug in 3 for x. I said 2 times x was 3, it's 6. The slope is 6, and then I'd have to find the y-intercept for that line. Because it's a line.
Mhm.
And to find the slope, to find the y-intercept, here it says plug in my x and y that I'm given. Does this make sense?
Yes.
I can make it prettier. I'll try to make it prettier and post-it, but like this does work for you, like if I make it more clear.
Yeah. Yeah, this helps.
Can we do one more question where
You
we're
can do
just
as many more
finding?
questions as you like.
Well, I don't want to take your whole Saturday. What was the time? It was from
You know
10:30 to when?
You know what? I
I
just
guess
said
we can go over at least one more. That's fine.
I will tell you when I'm done. How's that?
Oh,
If you
I
have to
feel
go-
guilty.
If you have to go, you're welcome to
No,
go.
I don't have
I'm
to
not
go, but
holding
I
you.
feel like I don't want to.
No. I'll tell you if I have to go. Actually, I would have had to go if I was moving, but I'm not moving this weekend. Next weekend, I'll probably have a little shorter amount of time unless I get a lot of the move done during the week.
Oh, wow.
But I'll
This
try
is a
really
good
hard.
one.
This is a good one? Well, then do it.
Yes, this is a good one.
I like it. Do it. And then If you like somebody, how about this? One person, pick yourself, volunteer, and think through it, and I can correct your thinking because if I keep telling you how to start, it's not going to help you. And we'll do that for each one of you. Whoever feels the least self-conscious, unless you don't know how, do you know how to do it right away?
Practice. I'm still gonna
Wait,
practice.
Lauren, here's my question. Do you know how to do it because you know what it means, or do you know how to do it because you memorized how to do it? That's my question.
I was gonna do it. I'm just gonna do it over again. We'll see. I'm just gonna do it.
Julissa or Carmen, do you want to volunteer to do this? I'll walk
I'm
you
doing
through
it now. I don't
wanna
think
do
I'm
it
the
out
one.
loud. I want to do it
Oh.
out loud. I want one person to
Okay.
volunteer out loud because I want to see where we get stuck.
Can we have the formulas back on there?
Yeah,
Just
sure.
from a sheet.
Absolutely. Always have the formulas. Don't worry. There will be a
So,
moment when you've done this so many times, you won't need that formula sheet for most of it.
in my mind, I would break out. I would start with number 2 first, maybe.
I just want to know here, I want bigger steps now because now we've broken it down. You don't have to break it down for me anymore. What I want to say,
Okay, so
the first thing
what
I
I
want to
have.
do is what I want you to think in terms of is like my first step is take the derivative.
Yes. My first
Okay.
step is take the derivative. I had it as 2x. 2 parentheses x to the squared, and then I have
You missed
x.
something. No, you missed something. Look
Oh.
again. This is x to the third power.
Yeah. Oh, I thought I would separate it. Like
We did. This is 2, and now x to the third power. I want you to take the derivative of that.
I thought it was x squared times x to the first. No.
No, we don't do that.
Yes, that's what I
No, never
think
do
I did
that.
wrong.
Oh God.
N is the 2, right? N is the 2. Number 2.
Nope. 3, because this comes from
N
here.
is 3. Oh, why did I do that?
No, but it's good
Okay.
because this is
So
how
no.
I can, like literally, when you do it, we can figure out what's where things are going off. If
Because I'm not applying that formula. Then it would be
doing it, you won't get it.
3x. It would be 2 times 3x 3 minus 1.
Or 2.
Oh, or 2. Yeah.
You don't have to
Oh,
write -1. You can write
2
3x squared.
x squared. I just do that until I memorize it. And then
Don't memorize it. Don't memorize it. Use the formula sheet. I promise you, within like the next homework, you will use that formula sheet less and less. You can use it completely right now. You're just starting to learn. I promise you will not use it for this for very long. You will, maybe these, you'll use it, but the top ones you won't because you'll do it so many times. 2 times 3x squared. Good. What else? We only did this.
And then we're moving on to the 3x squared plus 3x
Right.
squared.
But you have to take the derivative of it. You can't take the derivative of 1. See, here I wrote the derivative. And let me say that the steps that I do it and the way that I do it and just watch how I'm doing it. I'm going to go down. I'm going to make sure I take care of everything piece by piece. I'm going to label everything. I don't get down to the end and go, what did I just find? F prime of x, which means I'm taking the derivative of f of x. And I start
So then
with
it's
2 times x cubed. You did perfect. Plus.
Then
3.
the top, we would take the top one, which is the k and the f of
We're
x.
on
No,
this.
that's not a squared.
We're here. Don't help her. I really
Okay.
want her to.
I'm trying to figure out which.
Okay.
You got this. Don't worry.
Wait. Don't anybody talk. Don't anybody
This is
talk.
so embarrassing.
What is, I have 3x squared, but if I look here, what do I have? I just have x to the n. What do I do with that 3?
Break out the 3. Yeah, then it's 3 parentheses x
Read it carefully. Match
Okay.
it up.
No, 2x
Yes. Yes.
to, yeah. And then it's just,
2x.
yeah.
You got it.
Ah,
Now,
struggle.
see, do you see how important it is for you to struggle through it a second?
Yeah.
It'll be fine. You won't, once you struggle once or twice, it'll start coming quicker and quicker. Don't worry.
And then it's
Yeah.
subtract.
Yes.
And then it's the same thing where it's 120 and then just
Good.
x.
Times the
And-
derivative of x.
Yeah, times the derivative of x, sorry.
Which is?
1.
Yes. Which is minus 120.
And then
Right?
that's 0 for the 5.
So
Okay.
now we know the derivative, and I'm just going to multiply this together. Nothing major. That's all I did, just to make it a little cleaner. And here's what I'm just going to point this out to you. You don't have to go just to skip a step, because I told you as you started to get like more and more familiar, I'll try to make it faster. All you have to do is multiply 3 times 2, 6, and take the degree down by 1, 6x squared. Same
Oh.
thing, next one, 6x minus 120. See?
Oh, wow.
Can
It's
you
very
repeat that again? All you do is you said multiple.
So all you're really doing in all the steps that we're taking, and I wanted to take the steps you see what's happening, is we are multiplying this 3 out in front, aren't we?
Yeah.
It's
See,
just
but that
43
wouldn't that be a
times
different
2.
kind of equation?
No, 6x squared. I mean, that's all we're doing here. We're saying 2 times the derivative of x to the third, but the derivative of x to the third is 3x squared. I know I have to multiply it by 2. It's going to be the exponent times whatever the number is in front of it, and then I bring it down 1 degree. The exponent.
Oh,
You see it?
that makes it simpler. I like it.
Yeah.
Like if I said, what's the derivative of 15x to the 4th power? Well, it's going to be 15 times 4, which is 60, x to the third.
And then it's going to be x squared plus x minus 20 is the
Where-
final derivative formula.
No, forward here, 6x squared
Oh.
minus, we can't change it unless we do something different. You want to factor out a 6, we can. I'm okay with that. This is fine with me. And it's also fine with me for us to factor that, but I don't know if we have to.
Oh.
But let's see what the question says. We took the derivative and we know how to do it now. Do we feel more and more comfortable as we do this?
Yes.
Yeah.
Good. See?
That's just the final, that's
No,
the
it's not
derivative
final
of that
anything.
problem
That is the derivative.
of the
Any of my
function.
questions.
Well, no. I meant as far as
That's the derivative.
as far as discovering the derivative.
Yeah.
That is the derivative of that function that is stated.
Do you see it? Like I want
So
you to
yeah,
be able
I know.
look
I just
there
want to
and
make
say-
sure that that's the final form of what, like
Yeah.
when I write it.
Well, you can make this the final form, you can make this the final form, but I'm not sure what the final form is going to be because I haven't seen, it didn't just ask me for the derivative. It's asking me something else.
I guess I was saying as if the problem did ask for the derivative. That's
I'm
how
done.
it.
Yeah, I'm done. Absolutely. Does that make you feel better? Like that's the derivative.
Yes, it does.
You don't even have.
Because sometimes I feel like I'm not figuring out what I'm
No,
not
you're good.
solving the question. Yeah.
You're doing perfect. You wouldn't have to go past here. You might even be able to plug this in. I'm not really sure what it will take. You know what I'm saying? But you need to be able to at least get to the first line. You could try plugging that in and see if it works. I don't care. But, I think cleaner would be the second or the third line after. I mean, either one of those. But that's not the question. Now it says 2 horizontal tangents. Uh-oh, what does that mean? What does horizontal tangent mean?
There's a high
Think
point and a
about-
low point.
Think about what does horizontal mean? Horizon,
Yeah, horizon. Yeah.
horizontal.
X equals.
Don't think too far ahead of me.
Oh.
I want you to understand what a horizontal tangent means. Is that a horizontal line?
Yeah.
Yes.
What would the slope of that line be?
Y equals 0.
Zero.
0.
It doesn't have when there's no slope, it's 0. I mean, a straight
Right.
flat line is Florida is a 0 slope mostly.
Okay.
I want to find two horizontal tangents. And what does the derivative tell me?
Then
It gives you the slope of the tangent line.
Yes. And we just said the slope of the tangent line is?
0.
I'm going to say 0 equals 6 times x squared plus x minus 20.
Mhm.
Does that make sense?
Yeah.
And then what could I do next? Factor. Well, I can divide both sides by 6 because obviously it's not going to matter.
Sure.
It's still going to be 0. I just want to factor this. I get 0 equals, factor this for me.
X. 5. X minus 4.
Perfect. That means I have
Oof,
two
I would've had it wrong.
solutions. X equals what? Give me my two X's.
Negative 5. That's it. Negative 5. Because the other
No.
one was positive 4.
I have two solutions.
But isn't that a positive value?
I have two solutions. This is going to go in here. This
Oh,
is gonna
I'm
go in
sorry. I didn't read the bottom question.
That's it. Because I said
Okay.
it equals 0, it's going to give me I found the derivative, which gives me the slope of the tangent line. Well, the horizontal, the slope of the tangent line is 0. I said it equal to 0 because that's my derivative. And then I just find out what x is. There's two different places where the slope is 0. Basically, it looks like this. There's a slope of 0 here, and there's a slope of 0 here. And they're just asking you to put it in separately so that they can grade it properly.
Would the question ever ask for the y values
Yeah, it could
of a
ask
vertical tangent?
of a vertical tangent. A vertical tangent would be, there would be no.
I just made that up. I don't even know if that is.
Yeah, no, don't worry. Don't try to complicate things.
I'm just trying to figure out all the possibilities because sometimes I think I study.
You'll
and
never be able
then
to figure out all the possibilities. How's that?
Well, I mean, like,
All
for
I
me,
want you to
like,
do, no, listen, that's like saying to a friend of yours, we're going to sit down and we're going to try to figure out all the different possibilities for the way our lives are going to turn out.
yeah.
So you can come up with how many? Maybe 100, maybe 1,000 if you really worked hard on it.
Mhm.
There's infinitely many ways that your life could turn out, I'm sure.
Yeah.
Every decision you make changes things.
Mhm.
Yeah.
Same with math. Don't try to think 20 steps ahead. Just try to go to the next line. Try to figure out what you're trying to do. Then do the first step. The first step was take the derivative. What do I do with the derivative? Well, I want to find horizontal tangents. Well, that means that the slope is 0. I set the derivative equal to 0, and I find two places where two x values where the slope is equal to 0. Oh, that's what the question asks. All the rest of it is step by step, just algebra. And I know I say just algebra because I know sometimes that just algebra is not just algebra for you, but I'm trying to differentiate what things are what. The algebra is the algebra. If you're having problems with the algebra, we can talk about it separately. I'm happy to help you with your algebra. But if we're talking about calculus and derivatives, we have to leave the algebra out of it as much because that'll confuse you if you're confused about the algebra. I don't know if that made sense what I said.
No, that's exactly what my problem is.
I'm happy to help you with the algebra at any point you come and say, I have a really hard time understanding all this algebra. And we'll go through and I'll see where you're having problems. But don't get that confused with the calculus part because it will kill you. Understand what the calculus part is. The calculus part is here. Find the derivative, horizontal slope, that means it's zero. That's the conceptual part that you have to know so that you can answer the question and do your algebra. That's why I say algebra is really important, but understanding what you're doing is really important too. It's not one or the other. Does that make sense? Is it true for you
Yes.
what I said? Do you feel like it's true for you what I said? All
Yes,
of you.
Yes.
Yeah.
for sure.
Starting to make a lot more sense now that we've kind of figured out what this formula sheet is and what everything means and how to use it.
Yes, I like how you drilled down the derivative. It's the slope of the tangent line.
When I make those videos and they're like short, I want you to know how hard it is for me to make them short. Every word I'm saying, because I'm deleting words sometimes, every word I'm saying, listen, it's not, don't just go blah, 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 blah. How do you do the problem? Because what we did today is I actually probably replicated a lot of the video. I'm hoping I replicated a lot of the video.
I do have one question on 15. I was doing it on my own and I knew that I got it wrong. Of course, I put in the answer obviously to get credit, but I know I got it wrong. So that's why I really want to go over this one.
Let's do it.
I
So
put
I just
in,
want to say first thing when you read this question, let me just read it. Well, first of all, does everybody understand revenue, cost, and profit? Like real,
Yes.
Yes,
what's revenue?
it's how much they sold it for times the value of the units.
Times the units.
Yeah, revenue is basically like if I started off in the morning in my store with no money in it, it was just an empty cash register. And at the end of the day, and I didn't take credit cards or anything like that, I just had cash. But at the end of the day, when I count my cash, that's my revenue. It doesn't take into consideration whether I made money, lost money, anything like that. It's just how much things I sold. Go ahead, continue. Then cost is when you start saying revenue equals, then I know it's something that you're having to memorize. But if you understand revenue, let's say revenue is how much money, when I go into the store, the revenue that they make for me is how much I pay them when I leave.
Right.
Let's say I bought 2 candy bars for $1.50 each. And I bought 3 bananas for 75 cents each and 5 oranges for 25 cents each. I would multiply each one times the price, and then I could add all that together. That's the revenue.
Yeah.
Make sense?
Yep.
Now, the cost, well, I bought 2, whatever I bought there, and I paid $1.50, but it cost me $1 each. My cost was 2 times $1. And then here it's 3 times, let's say it cost me 50 cents for that. And here I have 5 times 10 cents for this. The cost for selling all those products are $2 plus $1.50, that's $3.50, $4. And I made 3, whatever. I brought in that, it cost me this. The difference is the profit. Okay, that's it. If you know that, then you don't have to worry so much about formulas, although the formulas are important because we need them to do things. But I want you to understand what all those things mean. Now, anytime you see the word marginal, that means the derivative. It's a word, it's a business word for derivative. Because the derivative is really a really small difference between 2 values. And the marginal revenue is if I sell one more of those things, how much do I make? It's like, it's the slope of that line between the two. I don't know how to explain it. But anyway, don't worry about it. Marginal means derivative. That's all you really need to know. If it says marginal revenue, if it says marginal cost. If it says marginal profit, it means the derivative. First thing we have to do is what?
Solve for 6.
No, marginal.
Oh, find the derivative.
Find the derivative. You can't
Of
plug
the
in
given
numbers.
function.
Remember, you can't plug numbers into anything.
Mhm.
This is going to be important even later. You can't plug in numbers before you take the derivative, because if you do, you're going to end up with a number and the derivative is always going to be 0. It's
Right.
never going to work. You always
Right.
have to take the derivative first. What's the derivative? Let's say r prime. What's r prime?
Would be -5,
Mm-hmm.
and then you would do
2.
times 2. 2 minus 1, that would be 1. That would be like -5 times 2.
Q. It's not, this is the variable. This is
Right.
Q squared. That means n equals 2.
I know, I'm sorry, I was ignoring the Q.
Oh, no, the Q, see, R of Q, that's why I'm saying, and if I were to write that, and I'm just trying to show you, I said this was important, this would be the derivative with respect to Q. I don't have an X here. That's why at some point it's going to be important. Those, without using that, with just using primes, do you see how we get -5 times 2Q? That's all I need to know.
Yeah. Yes.
Perfect. And then what's the rest of the derivative?
300
Perfect. Because the derivative of Q is 1,
is
right?
1. Mhm.
Perfect. Hold on one sec. Let's clean this up a little. This equals -10Q plus 300. Good. We found the derivative. And then what else does it ask us for?
Is asking for the marginal revenue at 6 units.
What do you do?
You plug in 6, replacing Q with 6.
Exactly. We get -60 plus 300 equals $240. The marginal revenue at 6 items, 6 units, is $240.
This is so helpful.
Say it one more time.
I said this is helpful, like going through
Oh,
it
I'm
like
so
this.
glad.
Yeah.
No, I'm so glad. I'm so glad people are coming. I mean,
Because I wasn't thinking about putting it in the derivative first. I was plugging it in first and then trying
yeah,
to
you can't.
find a
Then
derivative
it's
after.
always
Like
zero.
that
That's what I
wasn't.
did too. That's
Yeah,
what I
my
did too.
flows was just always off.
Yeah. Well, it's always going to be 0 because
Yeah,
if you plug in,
that's
if
my
you plug in
problem.
6, yeah, it's going to be derivative of any constant is always 0. Those doesn't matter what it is, you're always going to get 0.
That's already in the derivative form. So I can plug in
So
the
this
the
says
thing. So it could be
these here are not derivatives, and the ones underneath are derivatives.
I
don't
want to
wanna
struggle
do
through
these.
it.
I'd rather correct you guys than do it. Because
Okay, I'll do it. Then in this, the first one would be 5 parentheses -5
perfect.
plus 3 parentheses 2.
Perfect.
Then it's 10, negative
No.
10. I'm sorry, negative 25. Yes. That would be the answer for the first one, which would be
Exactly.
-19.
Exactly. Super
And then,
easy.
yeah, then this is asking for the derivative now of
Yes.
5F.
Don't let the notation confuse you. I could rewrite it in different notation, but I kind of like for you to see if you can understand the notation. And you can look here too.
Can I, that's still 5 of f of 9, the derivative of 5 of f of 9.
This is
plus,
5 times
yeah,
f of 9.
yeah,
And then find the derivative.
derivative.
Yes. Plus, go ahead.
The derivative of 3g of 9.
Exactly. And if I were to rewrite this, I could say this is the same as what?
F parentheses
I
4.
want to say
Oh, wait,
5
no.
times
I mean, I'm sorry.
5 is 9, like that.
Yeah.
You see how that makes that? I'm using this.
The second one?
The first one.
Oh, the first one.
I
Oh.
use the second one to separate them,
Mhm.
right? Because we started with this, which
Oh, I
looks
see.
like this. Sorry, it looks like that.
Mm-hmm.
I separated it into 2 pieces. Yes?
Yes.
Yes.
Once I separated it into 2 pieces, I used those 2 pieces and I did this.
The first one.
Uh-huh.
And now that it's in that form, you can plug in
Exactly. Exactly. Right? Make sense?
Yes.
This is equal to 5 times what?
4.
Yes.
And then plus 3 times 5.
Here's the thing, there's nothing scared of. What's the worst thing that'll happen?
Being comfortable with being uncomfortable is hard.
Yeah, but like just the worst possible thing that could happen is you get it wrong. But I'll figure out why you got it wrong. I'll correct you, and then it won't be, then you'll get it. Like if you're
Yeah.
not willing to be wrong, you're not willing to learn.
I think I think here we use the second one to separate them. Would be 7.
Mm-hmm.
Let's use F. Is that what
Yeah.
you do?
7F, what? This is a prime there.
A prime.
At the
Yeah.
end. Like you can, I don't know if you can see it. There's a prime.
Derivative. Yeah.
That means the derivative. We're going to say 7F prime of 10. It should look like this.
What happened to the 3?
I haven't gotten to it yet.
And then you
Okay.
do plus 3 f of 10. I mean, g of 10, I'm sorry.
Plus 3g prime of 10.
All right. I see that.
Yeah, it's not this. It doesn't. Nothing disappears. If it disappears, except for constants, they become 0. But nothing else should disappear.
I see it.
Good. Now this equals what? 7 times.
Times 10?
No. Look, what's this?
Oh,
The first one.
negative 3.
Oh, I see.
Oh, wait. Negative 4.
Didn't you see it?
So 7 times negative 4.
Exactly. Don't make this hard.
I think I understand it. It's just,
I feel like you're making this hard. Like,
yeah, I think
And that confidence, the confidence of knowing that is what it needs to be like substituted with. Like
right,
just
like if you
I think it's
see
just building
F
our
prime of
confidence.
10, if you see F prime of 10, they're giving us F prime of 10.
Mhm.
There, we just plug it in. Negative 4.
Maybe when something's like too easy, it's like not believable.
Yeah,
Like, I
that's
just don't
what I'm
trust
saying, like,
myself.
sometimes
I don't
guys
trust myself
it-
either.
overcomplicating. I want you to know what I'm doing right now is making it easy. If you feel like it's complicated, then you tell me I'm not getting this because it feels complicated.
I don't think it's complicated. I just think I'm expecting it to be complicated and
It's
thinking
not.
too hard.
And it's making me
Say, just here, say what you really think, and if it's wrong, I'll tell you. How's that? You can feel confident that I will not let you get it wrong. Does that make sense so far?
Yes.
yeah.
Okay, what do I do next?
You do the 3 times negative 3.
3 times negative 3. What do I do next?
Then you add them you multiply them together. And you get negative 28
plus
minus 9. And then you get
equals-
negative 37 as a total.
And what does that do?
That's the answer for the first one.
That's the answer, exactly.
Yeah.
That's it. It's over. Okay. Now, how do I do the next one?
3f
so
prime of 10. 3 prime of,
Thank
how do you say?
I thought you were going to overcomplicate it again. Go ahead.
Minus 7 g of 10. G prime of 10.
You have to get the prime because there's also a G of 10.
Then
It's
you
not
do
hard. Here's the thing. You have to be very aware of details, but it's not complicated. It's just detail oriented. That's where the complication is in math often. It's complicated, not because it's complicated, because the detail is that there's a prime here, and you have to make sure you get that number and not that. That's all. Other than that, it's not hard. And it's not complicated. It's just details. This becomes what? Next line. 3
That's 3 times negative
times
4.
minus 7 times.
Negative 3.
3.
Perfect. Which equals minus 12 plus 21, which equals 9.
Yeah, that makes sense.
Can we go over the graphs for
We can go over
from
anything. I just want
the
to make
first
sure
homework?
as we go over them that we just make sure we get them. That's all.
I kept thinking the derivative was like the opposite of the value. Like, I don't know why I thought that, but
What I want you to do, I guess, is what I want to say here is first, stop taking notes while you're watching the video. Please. Because notice, have you taken any notes today?
no.
Have you learned anything today?
I'm writing
Yes.
it down.
A
Yeah.
lot more than the lectures.
Yeah.
The notes are not helping, are they?
No, it only helps.
they-
It helps while I'm solving it, like writing while I'm
Right, but
solving.
it's not helping you understand.
But it's not helping me understand though. Talking through it helps me understand it.
Yes. What I want you to do is stop taking notes. Watch the video. If you get to a point, and like you can go over it again. If you don't understand something, basically I'm going to repeat myself here. I'm going to go slower. I can also change the way I do it. I can do a lot of things live that I really can't do in a video because I wouldn't know to do it. But to see me if you don't understand something, but watch the videos without taking notes. It'll help so much. And then if you do want to write something down, stop the video.
Oh, yeah.
Don't let it keep running.
No. Yeah.
Because then you're missing maybe something I'm saying next. Does that make sense? Just try
Yes.
it. Lauren?
Yeah. Sometimes, yes, for sure.
Yeah.
Of course.
But you could even run it back again if you didn't understand what I said.
Exactly. That's what I do. I always have to watch your videos 2 times in order
And
to
then
really
if you run
understand.
it back again and you don't understand, then you just come see me in office hours. You can wait till Saturday. I'll do exactly this in office hours as well.
Yeah.
You just let me know you need help. I'm here, but we're going to make it Saturdays. But I don't want you struggling the whole week. Look how easy this was. Do you need to spend 20 hours struggling with all this homework during the week? And then I can show you how to do
Yeah,
it.
that's what I was doing yesterday.
So
I
that's
mean,
the-
yeah,
the
me
whole
too.
day.
I struggle. I study
the
so
really
many
best
hours.
thing, if you want to make yourself the most efficient and learn the most in this class, if you can, you may not be able to, but what I would do is watch the video. Don't take a lot of notes. Take very few notes. You can't use the notes anyway. Take very few notes. And then go see if you can do the homework. That's it. Just go from there and try the homework immediately. Don't try to learn more while you're doing the homework. Just see what you remember from the video. If it's nothing, but if it's something, then it'll reinforce then because you're trying it and you just heard it. A lot of people watch the video Monday, let's say, and on Friday they do the homework. There's a big gap between those 2 days, and you're going to forget everything you might have even learned from the video. Take the time after the video to try just to do a couple problems. But when I say that, don't watch more videos. Don't try to get the answer. Just see if you understand what it's saying. Does that make sense, what I just said?
Yeah.
Yeah, because I did that. I would watch, like, go through the all the material one day, and then maybe like 2 days later I'll do the homework, and then it's like
You
I
don't remember
don't remember.
Yeah, nothing is
Right.
there.
Even if you watch like 10 minutes of a video and then, like, say you have 20 minutes to study. I'm not even saying to study for hours. You have 20 minutes to study, watch 10 minutes of a video and see if you can find some problems that are about that thing you just spent 10 minutes watching
Yeah.
and see if you can do the problem. Even if you can't, it's not bad. But it will reinforce, think about what you just learned, and it'll start reinforcing what you just heard. And then you can always come at me.
That's what
You
I
don't need
do,
to
and
keep
then
watching.
I give up midway if I get like very
Yeah,
like I watch the
frustrated.
videos and then I go to the homework because I know I'm
Yeah.
gonna forget. So I go to the homework and then I guess like my brain gets overwhelmed and then I just like take a
fine.
break and
That's
then
fine.
I go
Perfect.
back.
Perfect. That's exactly what I want you to do. I don't want you to study more. I want you to like get things one by one, and they will build on each other. You'll see. Choose a graph of the derivative from those graphs. And the original graph is the one at the top. Well, I know a couple things. I know very little, but I know that the derivative is the slope of the tangent line.
Yeah.
That I do know. And I also know that wherever that tangent line is horizontal, the derivative equals 0.
Yeah.
Well, the tangent line is horizontal anytime there's like what we call this is a local minimum, because that's the only way I can get through one point. And up here, there would be, it doesn't go up any higher.
No.
Yeah.
Here, there's going to be a horizontal tangent line.
Mhm.
And also, let's say here, there's going to be a horizontal tangent line.
Yeah.
Even though we can't see the top.
You can't see it. Yeah.
Because here, if I made a tangent line, that's a positive tangent line, isn't it?
Yes.
And right here, this is a negative tangent line, isn't it?
Yeah.
And here, it's a positive tangent line, isn't it? And everywhere they switch, this is positive, negative, positive. Everywhere they switch, it's 0. Does any of that make sense?
But when you say it's 0, are you saying like,
The slope of, because here we're choosing the derivative of that graph. The derivative is the slope. I'm looking at slopes. Let's start again. I'm
It's a
looking at
horizontal
this
line at
original-
0.
Say again. Say it again. I'm sorry.
It's a horizontal line at 0.
Not at 0, when the slope equals 0.
Right.
Whenever I find the derivative, I'm finding the slope of the tangent line. The tangent line hits the graph in only one point. So far, I didn't write anything that we don't know.
Correct.
Well, there's a real easy place to look for a value, and that's, I know that the slope is equal to 0 when it's horizontal.
when I'm solving this problem, I'm looking for another place where the slope would be 0, and would that be the
Slope,
matching
this
graph?
is the original function, and I'm going to say, well, the slope of the tangent line when it's 0 should be here at 2. Would you agree?
Yeah.
I
Okay.
know at 2, whatever, 2, when x equals 2,
2, it's 0.
and
Y is
slope
0.
equals
I mean-
0,
Yeah.
which is the derivative.
Yes. But in the options that they gave us, I felt like there was 2 that had the same slope.
Well, wait, don't go ahead of me. Let's just
Oh.
think about what you thought. We're gonna think about what you're thinking now, because we've learned a lot.
Okay. Yeah.
We don't care what you thought. We care what you're thinking. Does this make sense?
Yes.
Good. Now, if this is graphs of the derivative, anywhere that x equals 2, I should have a 0, shouldn't I? That graph looks good. That
Yep.
graph's no good. Can't be that one. This graph is no good because there's no 0 at 2. It's either this one or this one. Let me erase my lines because you keep moving.
Yeah, sorry. Because you
That's
can't
okay.
really see the whole thing
No,
now.
I just want to make sure that you know what I'm saying here.
Yeah.
Yes.
These graphs are the derivative of the top one. Then when x equals 2, my slope has to equal 0. My slope is the derivative. It has to be this graph or this graph. For sure, it can't be the other two because the other two don't have the derivative equal to 0 when x equals 2.
Uh-huh.
Does that make
And
sense?
then, yeah.
I'm going to say it can't be this one or this one. Now, we just want to see if it's going up or down here. I'm going to erase all these things because we understand this so far.
Yes.
Let me erase these things. Now you can go up a little. We know it's the top or the bottom. Now, where else does the slope probably equal 0?
You can't really see where it.
Yeah, it's probably -2 though. And I think both of those have another 0 at -2. We can look. You can see if at -2, the two graphs have zeros. See, this one does. I just don't know if the other one does. This one has a 0 at -2.
Yeah.
Can you pull
No.
it down a little bit for a
Yeah,
second?
Oh, sorry.
yeah. And the other one does too. We're still to the place where we know it's either the first one or the last one. Agreed?
Yes.
Yeah.
Now, go back up to the original graph, please. We start off here, and is my slope positive or negative?
Negative.
Positive.
Oh, the start. Oh, I'm sorry. I was thinking about as it approaches 2. Sorry.
No, but it's the slope
Oh.
there everywhere until we get up to that top is positive. It's not constant, but
As it approaches -2.
as it approaches -2, it's positive. We don't.
Yeah, it's positive.
It's not, yeah, it's not.
I was looking at 2,
Gotcha.
not -2. Yeah.
Gotcha. No problem. So you understand that. That means when I'm less than -2, my graph has to be positive, doesn't it?
Yes.
Do you understand what I just said?
Yes.
Say,
For the
yeah.
first one. But in this
Wait,
situation,
Let me just repeat. Let me make sure everybody
Oh.
stays exactly in the same place. I just want to make sure everybody sees that this is a positive slope, no matter where it is, up until the top.
Makes sense.
And it's not a constant slope, it's positive. I mean,
Yeah.
it's probably bigger down here than it is up here because it's getting closer and closer to 0 as it gets to the top. But that's not important, it's still positive. When x is less than -2, we should have a positive for my derivative. Agreed?
Agreed.
Everybody?
Can you repeat that again?
Absolutely. When when my graph is less than -2, my original graph here, you with me?
Yes.
Are you sure?
Yeah.
When my graph, let me get a new color, is less than -2, the slope of the curve is always what?
positive.
Positive?
Positive. Do you see that?
Yes.
And then here we are at -2.
Mhm.
When I'm less than -2, is my graph positive or negative?
Gonna be positive.
My graph,
Positive.
not my slope. My graph.
Like
Oh,
this
negative.
this
These
part
are
is gonna
all negative numbers.
Yeah. I was talking about this part, sorry.
But I want you to, like, here's where you have to switch your thinking. On the original one, we're talking about the slope because we're finding the derivative. When we're looking at the graph of the derivative, we're not looking at the slope anymore. We're looking at the actual values.
Good.
You see that?
Mm-hmm.
No.
No? For the
When we're looking at the graph of the derivative, we're
Okay,
no
so
longer
here,
looking.
let me erase this. Let me start here. We're in the top graph, okay?
Yeah.
And in the top graph, I'm looking and I want to know I'm going to choose the graph of the derivative of that graph.
Yeah.
The slope, the derivative is the slope of the tangent line.
Mm-hmm.
Anywhere along here, wouldn't the slope of my tangent line be positive? Up until -2. Because this actually goes like this, kind of, pretty much. It's more clean, but yeah. And at -2, it's the maximum.
Yes.
Do you understand that for this graph, I'm looking at the slopes? Because that's the derivative, and I'm trying to find the graph of the derivative. Is that a yes from everybody?
Yes.
Yes.
Good. Here, these are the derivatives. I'm looking at the values. I'm not looking at the slopes anymore. Because if the slope of this line is 0, then my value at -2 has to be 0. It's not the slope as 0 again.
Mm-hmm.
Everybody get that?
Yes.
Good. Here, everywhere up until -2, I could pretty much say my slope is positive. It has to be, isn't it?
Yes.
And here, everything up to -2, are my values positive or negative?
Positive.
No.
Negative.
Wait, you said up until -2?
Yeah, from -infinity to -2, are my values positive or negative? Negative,
Is it not housing? That's
not
how I
the
don't
slope,
understand.
not the slope, the values.
The thing is, I think she's getting confused because the top you're looking at the slope, but at the
I know,
bottom
that's what I'm trying to
ones,
say. This, we're looking at the slope, and this, we're looking at the values. When I say that the slope I'm saying the slope from -infinity, here, from -infinity to -2 is positive.
That part I get. It's just I don't
Okay,
get how I'm observing the values.
I'm just going step by step. I know that you understood that part. Now, when I ask for the values, here's negative. Let's work on a different graph. Here's -2.
No, but this is the one I did.
No, I don't care. Here's -2.
Uh-huh.
When I'm less than -2, are my values positive or negative? My y values. I'm looking at my y values.
Oh, they're positive.
Well, they're negative until -4, and then they become positive after -4. My y values.
Oh. I'm sorry.
Okay? That's
Yeah,
why I
I'm sorry.
wanted
When
to
you said
start in a different
values,
place.
you're
That's
talking about
why I wanted
possible
to
points
start
on
in
the
a different
line.
one. That's why I
Okay.
wanted to start differently. Here, I could say all my values are positive here and here. Those are all positive.
Oh, yeah. When
Anything
I was
below the x-axis, these numbers are all
negative. Yeah,
Okay.
I'm sorry.
You don't have to
Uh,
apologize.
when you said values, I wasn't thinking about
It's
the
okay. I
actual like points
understand.
on the.
That's why I'm
Yeah.
slowing down. No, I do understand the confusion, I swear. Here, I'm looking for my slopes. Once I find the slopes are positive or negative, I look, but these are the graph of the derivatives. They should be positive or negative, the y values, because that's what I'm graphing. We all said that from -infinity to -2, my values are all positive. But on this first graph, from -infinity to -2, my y values are all negative. Not my slope, my y values. What's the y value here?
-1.
What's the y value to the left of that? Here, this is -1, and here, this is -2, and this is -3.
Yeah.
And it doesn't really matter what number I go to, they're all going to be negative. This graph is not coming back up and going positive ever.
Yeah.
The further to negative infinity I get, it just becomes more and more negative, doesn't it? My value. But I want them to be positive because I said the slopes from negative infinity to -2 are positive.
Yeah.
But those are negative. Let's
Yeah.
look at the bottom one that we said was the other possibility. And now, what are the values from negative infinity to -2?
They're all
Positive. And then let's go, and then here from +2 to infinity, the slopes are all positive again, aren't they?
Yes.
But look, from +2 to infinity, the slopes are all positive. And then if we go back down to that graph, and we can see that graph completely, the top one, we can see that between +2 and -2, the slopes are all negative, aren't they?
Yes.
And if you look at the graph, go down to the other graph, these slopes, these values are all negative. This is definitely the graph. That graph is the derivative of that graph. We just looked at the zeros, the positive slopes, and the negative slopes and matched them.
Can we do 15, the next one?
You can. I'll watch you. I don't want to
Okay.
do.
No, I
want you to like figure out what you don't understand. That's the most important thing.
For this one, the tangent line is at 0.
Is 0 at x equals 0.
At x equals 0.
Exactly. What possible graphs now? With just that information, I can eliminate quite a bit, can't I? Well, what's the value here when x equals 0? Here's x equals 0. What's the value of y?
Y is 1.
That's not 0. It can't be this one. Because you said at x equals 0, the slope is 0. Is that what you said?
Yes.
Is the slope 0 on the graph underneath?
No, it's not. It's 1.
How about the next one?
Okay. The next one over to the that one is wrong too.
Exactly.
Because that's another slope of 1.
Exactly. Now we know it's either the first or the last. Now,
And then,
go ahead, please.
and then I'm gonna look at which direction the slope is in the original
Yes.
one. And it's a positive.
How do you know what makes you know whether or not the slope is positive or negative?
Honestly, because I'm just looking at the parabola and I know it's positive. All the values are going positive.
No,
And I know that's not what I should be thinking about.
slopes are like, yeah, like if you have a graph and you have, this is a slope, the slope of this is positive because I always read graphs from left to right.
Yeah.
It's going up.
Yeah.
If it was going like this, the slope would be negative. This is going down. So far, so good?
Yeah.
Now, if I look at this graph on the top, well, the tangent line at this point here, would it be positive or negative? What would the tangent line look like?
It would just be constant, like it's a 0.
No.
So it would be a constant line? No?
It's a line, but is it have a positive slope or a negative slope? Because remember, if we talk about tangent lines, what is a tangent line? Just in general, not you don't need to give me anything formal. How would you know if you had a tangent line?
It only crosses the parabola one time
Perfect.
at
See?
one point.
You know stuff. See? You know that.
Yeah.
If I were to only touch that parabola in one point, like at -1, would the slope
Yeah.
at that point be positive or negative?
I guess, I mean, it
I
would
don't
be,
want you to guess. I want you to like have some form of certainty. It's a really easy question. I don't want you
I
to.
feel like 0 isn't negative or positive, but
Well, 0 is only in one place. 0, it can't be, so can be 0 everywhere. This has a slope of 0 everywhere. That's the only thing I can see on this page that has a slope of 0 everywhere.
it's a slope at x equals 0 to negative, I mean, to positive infinity.
From 0 to
Right.
positive infinity.
Yeah, it's
So is
positive.
the slope positive? It's positive?
From
that what you
0 to positive infinity, it's positive. Yes, the slope is positive.
Perfect. We already ruled this out. We already ruled this out. Which graph from the top and the bottom has
From
when x
0
is
to
0,
positive
the
infinity.
values are
The first one.
exactly. And then when it's less, it's negative.
Yeah.
That is negative. Those are negative values. I'm going to erase all my writing so you can see what we want to see.
It just basically has to match what's going on with the top one.
You have to look for the slopes of the top one because the derivative is the slope of the tangent lines. So all the slopes of the tangent lines less than 0 are negative. I can't make a positive slope. If I made a positive slope, it wouldn't be a tangent line anymore. It would be a secant line because it would go through 2 points.
Yeah.
The only way I can make it go through 1 point is if I keep it along the side. And I can't make it positive because it is negative. And on the other side, it's positive everywhere.
Mm-hmm.
I can't make it negative. If I made it negative, it would cross 2 points. It'd be a secant line. Rising things. I want you to understand. Here's a new question. Similar concepts.
And this one is asking us what the derivative of that graph.
It says at the point shown, so you see the point,
Mm-hmm.
which of the following is true? The derivative is greater than 0, the derivative is less than 0, or the derivative is equal to 0. And I'm not going to, nobody answer unless I'll let you answer in a minute. Actually, everybody can answer, but don't explain what you think is.
Yeah, I think what I think is it's this one. I think this is
We have the derivative is less than 0 as one answer. I need 3 answers. Don't trust her. She doesn't know for sure. And I'm
yeah,
not
don't trust me.
You can pick any of the ones that are there. Think about what you're looking for. What does it mean for the derivative? What does the derivative mean? That's what every time you see derivative and you're not sure what to do, think about what the derivative means. Julissa, any ideas?
I feel like the derivative is less than 0.
Lauren and Julissa say less than 0. I'm still not agreeing or disagreeing. What do you think, Carmen?
I think it's less than 0 too.
You're all right.
Ooh.
Because the slope is going to be like this. And that's negative. It's
Right.
less than 0.
Mm-hmm.
That's it. You don't have to really complicate this stuff. I promise. It's really that simple. Once you kind of get the concept, it really just repeats. It's the same over and over again, I promise.
I have a question. Can we go back on number 18 or no?
I don't care.
Is that okay, Jalissa and Carmen?
Yeah.
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 Just want to make sure that everyone's okay with that.
Yeah.
I'm pretty sure they're all okay with whatever you want to do.
All right, so we go back to number 6. And it was 18. I remember
Oh yeah.
the
This was one
formula
of them.
sheet. That's here at least. I see where to go.
Now do you see how important it is to understand exponents? Remember
Yeah,
stuff that we did in the first month?
it
was
matters.
algebra. And it was important that you understood it because now we're going to use it as if you know what it all means.
Got it. Oh, with the 1 here.
Yeah. This is the same as, if you don't understand this, you need to go back and watch exponent videos. And
Like
if you,
10x1.
this is 10x to the 1/2 power.
1/2 power because it's a square root.
The radical, yes.
To get rid of a square root, you put a 2 here, right?
2. I would write this as 2x to the -6 power.
Yeah, that one makes sense totally. The 2
you-
comes from the square root.
Yeah, we have the rule that says a base to a power over. If we have a fractional power exponent, this is the same as b to the m, the nth root of b to the m, which is the same as the nth root of b to the m power, which is the same thing as that. Those are all equal.
Yeah.
That means this is x to the 1/2 power and x to the -6 power. And then when I take the derivative of this, what I get? I just use my power rule. It works for fractions, it works for positive and negative, it works for anything.
The answer would be
Did I
this
lose
then.
y'all?
Wait,
Did I lose anybody?
yes, but hold on. I'm just trying to work it out.
Carmen, I would really like it if you went back. Maybe I can give you some help with where to go to get some more algebra help. Because I have some algebra videos from my intermediate algebra, which is probably where I explain this the most.
Yeah, it helps me so much. It helped me so
I
much.
sent Lauren there. Yeah. I'll show you how to go there because what you're getting stuck on is still your algebra.
Yeah.
Don't worry about it. I'll send you back. Let's finish this
Okay.
problem. Let's say you know how to get to here.
Yeah.
Now we're just going to use this and this, but I don't have to keep separating it. I can say this is 10 times 1/2 or 5.
Yeah.
X to the 1/2 minus 1, which is -1/2 power. Do you see how much quicker you can do it once you get used to it? I'm not saying you have to do it this quick. You can take 10 steps. I don't care.
Do
What
we
I'm
take
saying is
10
I'm sorry,
times?
how do we get from 10 to 5?
We get
10 times
10
1/2.
is
Because that one.
Oh, yeah, because it's,
Yeah.
yeah.
10 times 1/2, which is 5. And then 1/2
And then
minus 1/2.
1. So now,
it's I get the 5, but then the
Mhm.
x is 1/2 minus 1,
X. What's 1/2 minus 1?
then 1/2.
It's -1/2. This is 2.
Negative 1/2. That makes sense.
And then this would be minus because I'm going to multiply 2 times -6.
I like the 2 over 2. I think that was awesome. Minus 12. Yeah, that makes sense. The 2 times -6. And then x times
Not
oh
times.
negative
it's still
negative
x negative 6.
No. Seven.
negative
no, no,
7.
no.
Subtracting
Oh.
one.
Negative 7.
-6 minus 1 is -7.
Makes sense. Yeah.
This is the answer, but it's not probably the form they want it in. The form they want it in is 5, just because of the way they've written it. It's not that this is incorrect, but they, like, since they wrote it in this form, they want it in this form, I'm pretty sure.
Because you take
Yeah, that is the form they wanted it in.
Yeah.
It's
5.
because I don't.
5 times, there's a negative exponent that you just goes to the bottom, right?
yep.
Mhm.
And x to the 1/2 is equal to the square root of x. And I'll show you where to go for all this intermediate. It'll be fine. They're short videos and you'll learn what you need to learn. Lauren?
Yes.
Yeah. It won't take you long. It'll just have to be, it'll be a little extra time you put in. It'll be well worth it. I promise. If you don't take the time to do that, there's a really good chance you're going to either suffer through this class or you're not going to pass it. You need to have your algebra. Let's get this done and then we'll go back and I'll show you where to get the algebra from. Is everybody good with this?
Yes.
That's the answer.
Wait,
I mean, it should be the answer.
then 5.
I guess
Go ahead.
I was not understanding where the n went for.
If I have x to the 1/2 power, and it's in this form, you with me?
Yeah.
What's n?
N would be 1. No, 2.
No,
Wait,
One.
I'm sorry.
n equals 1/2. It's the exponent. X to the n. If I say x to the n equals x to the 1/2, what does n equal?
Oh, n equals the exponent.
Yeah.
But what I'm saying is for the derivative one, that
Yeah.
formula,
Yeah.
you see how it says,
Then it goes
X-
to here. N is 1/2.
yeah,
Now we're going to put that. Now we're going to do this. 1/2, because that's n,
yeah,
x to the n, which is 1/2 minus 1.
yeah. But then we just had it as minus 1/2. But where did that other half go?
X. Well, what's 1?
That's why
What's 1/2 minus 1? 1 is the same as
That-
2/2, isn't it?
yes,
What's 1 minus 2?
-1.
Right, 1/2 minus 2/2 equals 1 minus 2/2, which equals -1/2.
Yeah, I need to go back and review.
I'll show you where to go. I'll show you where to go.
Yeah, I think I'm just a little
that-
fuzzy.
Yeah.
Yeah, my algebra is the issue.
It's
My
your
algebra
I can tell you when it's your algebra. I'm telling you it's your algebra.
Yeah.
I promise.
know it
If
is.
I can tutor people one-on-one, I can figure out what the problem is. That's why it's really helpful when you start talking back to me.
I'm exposed. Yeah.
It's good. Like if you, let's say you couldn't read and you never wanted to tell anybody, do you think you'd ever be able to read?
No, definitely
So
couldn't.
tell me, I'll fix it. You'll be able to do math. I promise. What do we do?
We would take 7 and then we do a parentheses, then EX parentheses, and then we do
So,
plus
wait, with 7 and then the derivative of e to the x. And what's the derivative of e to the x?
just EX.
You don't need parentheses anywhere. Anyway, the derivative
stays
of
the same
first
way,
one is 7
right?
e to the x. Exactly. Nothing changes.
And then XE, I don't really know what the
That's different. Now you have to understand what e means. What does e?
Yeah.
ln.
No, it doesn't mean ln. ln means ln. E means e. What is e?
2.71.
It's a number. It's a constant, isn't it?
Yeah, 2.71.
Like if I said what's pi, yeah, 2.71 something, yeah. If I said what's pi, you'd say 3.14159, whatever part you'd say.
Yeah.
Mhm.
It's a number. That's it. It's a constant. They're both constants, even though they're not.
Know what it is.
Yeah, we don't have the exact value. It's
Mhm.
still a constant. It never changes.
Then we bring it out.
You have x to the e, which is the same as x to the n. N is a constant.
Mhm.
The derivative of that would be, believe it or not, I'll tell you what it is, then we'll figure out if you understand why. E x to the e minus 1.
That's the derivative.
Because the derivative is, if I have x to the e, that means n equals e. The derivative is n times
Yeah, it makes sense.
x to the e minus 1.
Oh,
Okay.
that's what I did not get in the homework.
And because we
So-
don't really have a value, like you would say pi minus 1, you wouldn't put in 2.14. That's not really what pi is.
No, I don't even know what pi is actually.
Well, but you know it's a number.
Yeah.
You know pi is equal to 3.14.
0.14.
Oh, yeah, true.
Blah.
Yeah.
It's always going to be equal to that. I would put, if it was pi up there, I would put pi x to the pi minus 1 because I don't know what pi minus 1 is. It's pi minus 1. I don't know what e minus 1 is. It's e minus 1. Unless I don't care about it being exact, but I do care about it being exact, and I don't really want to put in 1.71 because it's not an exact value. Does that make
Mhm.
sense?
Yeah.
That's it.
Then 7
And then for the derivative, it would just be 7e
7
So
e
that-
to the x.
e to x plus x e minus 1.
E x to the e minus 1. Because you bring that, remember, you bring that exponent forward. N is equal to e.
EX and then E minus 1.
Yeah, I was having
Oh.
troubles
You
yesterday
have to put
putting
parentheses around that e, I think.
because I was like,
In
I was
parentheses.
trying to and I didn't know.
Yeah, there you go.
I had to like back up. I'm glad that you told me about the parentheses because I
Yeah, you
didn't.
have to put parentheses.
That's good to know.
Yeah.
Does that make sense?
Because yesterday
Yeah.
what I did yesterday was I did 1 and then I went here and then I did e minus 1
I gotcha.
because it
No,
wouldn't
you
let
can just-
me.
Yeah, no. What it's doing is it's saying you have a value to a power, and then it wouldn't expect that. It would expect the next numbers to be like that. You put parentheses and then it puts it together.
That's good to know. Thank you because that helps for tests and
Absolutely.
stuff like that.
Yeah.
There we go.
This is what I'm talking about. Wait, no, but this is an example I'm talking about. You can't do the homework. It won't tell you if you got it right or wrong because
Yeah.
you already did it.
Yeah, but then you can go to it. Can't you go to a?
I would have to select a different problem. Would it tell me if I got it right or wrong?
Yes.
Yeah, you have to do just click similar question and it'll give you the same,
Yeah.
a similar.
And then it tells you.
Okay.
You click it over.
See where it says similar question up there? You just do another one.
I see. All right. Thank you so much, Professor Draper. Helpful.
What's the best way for us to do this? Saturday's good, but maybe we should also meet like on a Wednesday night. Or
Yeah, it's fine.
I have Tuesday and Wednesday night available. That way you can watch. I just want to make sure you watch the videos first because
And
I
then
don't want to do all the lectures every time.
Sure. I mean, I did watch the videos. It wasn't like a
The reason I did that whole lecture on what is a derivative, because it's like, if you don't know what a derivative is, it's not good.
yeah, no. No, because it's the
Yeah.
whole section. It's the whole section.
Calculus is derivatives and integrals.
Yeah.
Half of calculus is derivatives. If you don't know what a derivative is, half of it already you don't understand. And if you do the same thing when we do integrals, then the whole semester's gone. You can maybe get correct numbers somehow, but you will have no idea what we did.
what's going on? Yeah.
What a waste of time and money.
Yeah.
Correct.
And the ability to think in a different way. Do you see how this is going to change the way that you approach problems?
Yes,
Yeah.
100%.
Always my goal. My
Talking
goal
it out
is-
has definitely helped.
Yeah. And I want you to learn how to talk it out to yourself. But it starts with us talking it out together.
Yeah.
Until you really understand what the question is asking, don't start the problem. It doesn't make sense because you're going to get a whole paper full of all kind of stuff that you don't know what it means and you don't know when you get to the end. Agreed?
Agreed.
Okay. Before you start, like if we start going to do this problem, I'm not saying like read it and memorize it. Read the question and find out what they're asking. I'm looking here. I'm not reading everything. They're giving me a function and they want me to find the derivative. That's the first thing I notice. And I can read through it and see if there's anything else I need to know, but I'm looking for the derivative of that. From here, this is the first question. I'm like, Find the derivative. Is there any, then I can read through it and see if there's anything else that I might need.
Mhm.
But like, at least I know what track I'm on. I'm on the track of I need to find the derivative. Oh, and then they want to know what happens to the derivative when I plug in 10. And here they want to know what that means. If you don't know, you can get both of those by getting numbers correct, but you won't know what it means.
That's true. Very
Right?
true.
It's useful.
Very, very true.
Up in the upper left-hand corner, see where that circle is?
Yeah.
Click on it. Slow down. Don't do anything. This is my YouTube page. And if you go
Okay.
where it says playlists and go down to the yellow, don't click on, no, don't click on that. Go where it says view full playlist underneath, because that'll just start playing the first video. View first, yeah. And now here's all intermediate algebra. If you're having problems with multiplying, dividing fractions, there's a, wait, slow down, go up.
I was just showing that I was watching these.
Yeah, like there's 11 minutes you can learn how to multiply and divide fractions. Least common denominator, 6.5 minutes if you're not sure how to find that. And then continue, you can go down, and you can show her what you saw.
I mean, whatever is red is what I saw. Whatever is not red is what I
So
did
then,
not see.
wait, slow down, slow, up, 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 up. Here's exponent rules explained. 9 minutes. And there's positive and negative exponents, the next video. And then if you go down,
What do you suggest which ones do I look at? Obviously,
you
this
need
one.
to, you need the one for, you know better what you need, but I know you need exponent rules explained.
I know I'm bad at fractions, so that I know. The
Right,
fractions.
positive and negative, maybe. I don't know how
Mhm.
you're doing with positive and negative. And down toward the bottom is fractional, way at the
Okay.
bottom,
Yeah, those are my
All the way
two
at the
areas
bottom.
as well.
all the way at the bottom, more.
Those
All the
are
way.
fluid.
I think that's the last thing we do. Yeah, there's fractional exponent.
What's the
So
fraction?
roots and radicals starts it, then fractional exponents, adding and subtracting radicals, I guess you can look at. But there's factoring is in there. Everything really, the basic algebra that everybody misses is in here. And they're pretty well edited. I don't know how, they're pretty well edited.
They're awesome. Absolutely amazing.
Thank you.
I learned how to factor because of you. Like literally
Okay.
everything from high school wiped out. You helped me like know everything I should have known.
And it's really easy.
Yeah.
It's
Now
like
it's
so
easy.
crazy how it's so crazy how hard we make things. I don't understand it. I would go here and go through the intermediate algebra.
Mhm.
There is a college algebra one. They're not very well edited yet. I've only taught it a couple times, so I just never get through all the videos.